Welcome back to Physics with Miyoshi, and we're going to talk about kinematics a little bit more and falling objects. Over here, we did a little bit of an example where we had a object falling down. Well, what about an object going up in gravity, in the effects of gravity? So if I have an initial velocity of 5 meters per second, hopefully you think about this, and if you think about it a little bit, as it goes up and it comes back down to the exact same place, it should have the same velocity coming down, or same speed coming down that it had going up. It would just be in the opposite direction. Well, we can show that mathematically here too. The other thing I want to notice to point out is over here, if you see these equations, you see that I changed these to have delta y's in them. I put a little comma there. These could be y's in these equations, as well as x's. So whatever dimension we happen to be working in, they can be there. So let's look at this though. The nice thing about vertical motion is that we almost always will have a known final or a known initial velocity. And in this case, if something gets to the top, as I throw up an object, it has to turn around, and as it turns around up on top, it receives a zero. It has a zero velocity at the top. So we know that the final in this case is 0 meters per second. So if I just look at this equation here, what is the time it takes to get to the top? Well, I can use the whichever equation it is, the acceleration equation, and I know the acceleration is gravity. But let's start out with the equation. Delta V over t, and my acceleration is g, and my velocity initial is, that's a v final minus v initial over t. I'll rearrange this guy so that t is my v final, which is 0, minus my v initial, and divided by gravity. So this guy is going to be, final is 0 meters per second. My initial is 5 meters per second. And divide that by g, which in this case is negative 9.8 meters per second squared. As long as we're on Earth, that equation will work. So now my t is going to be negative 5 meters per second, divided by negative 9.8 meters per second squared. My negatives can divide into be positive, and this will give me 0.51 seconds. Meters divides out, one of the seconds divides out, and then I flip it over to the top to be 0.51 seconds. So now, if we know this now is 0.51 seconds, to show that the velocity on the bottom is just going the opposite direction, what we can do is we can use the same equation here and just put in the different numbers. So if we have the velocity on the bottom, will now be our final velocity. So if I'll just come out right over to here, actually let's just do, well yeah, we'll do that. My final velocity, g, which is 9.8 meters per second squared. That is my final velocity, which is what I'm trying to find. My initial velocity is 0 in this case because it's up at the top. So this will be my initial, which is going to be 0. And then divide that by my acceleration, divided that by my time, which is 0.51 seconds. I can rearrange that equation, just multiply this guy times that. So my v final is 9.8 meters per second squared times 0.51 seconds, and that should give me a final velocity of negative 9.8, negative 5 meters per second. So this is what we call the symmetry, if you will, of falling objects. If I throw something up, when it comes back down the exact same amount of time, the exact same amount of distance, as long as we didn't collect air, friction, then this would tell you that the velocity at the bottom is the negative of the velocity going up. So, as long as it's the same time going up, same time coming down, or if it's the same position, when we're looking at dimension or constant acceleration, vertical motion, falling objects, then it should be the same. So we can use that symmetry, if you will, to solve many different problems, and we can see that we should be able to always find the something that we know based on the top or the bottom or somewhere in between, but we can always figure out motion in the vertical dimension. That's a little bit about falling objects and a little bit about symmetry, and tune in again for more Physics with Miyoshi.